Look around you. Your smartphone, television, computer, power bank, and even your car all contain a small but essential electronic component called a capacitor. Despite their simple appearance, capacitors play a critical role in modern electronics. In this video, we'll explore what capacitors are, how they work, the different types available, and where they are used in everyday life. A capacitor is an electronic component that stores electrical energy in the form of an electric field. Unlike a battery, which stores energy through chemical reactions, a capacitor stores energy by separating electric charges. A basic capacitor consists of two conductive plates separated by an insulating material called a dielectric. When a voltage source is connected across the capacitor, electrons accumulate on one plate while leaving the other plate. This creates an electric field between the plates and stores energy. Think of a capacitor as a temporary storage tank for electrical energy. It can charge quickly and discharge quickly whenever the circuit needs additional power. Let's understand the charging process. When a capacitor is connected to a power source, step 1. Electric current begins to flow. Step 2. Electrons collect on one plate. Step 3. An equal number of electrons leave the opposite plate. Step 4. The voltage across the capacitor gradually increases. As the capacitor becomes fully charged, the current flow decreases until it eventually stops. At this point, the capacitor contains stored electrical energy. Now let's look at discharging. When the capacitor is connected to a load, such as a resistor or a light-emitting diode, the stored energy begins to flow out. The capacitor releases its charge and supplies electrical energy to the circuit until it becomes empty. This charging and discharging process happens continuously in many electronic systems. Capacitance.
The ability of a capacitor to store electrical charge is called capacitance. Capacitance is measured in a unit called the Farad, named after scientist Michael Faraday. In practical electronics, capacitors are often measured in microfarads, nanofarads, picofarads. A higher capacitance value means the capacitor can store more electrical charge. The capacitance depends on three main factors: the surface area of the plates, the distance between the plates, and the type of dielectric material used. Engineers carefully choose these factors depending on the application's requirements. Types of capacitor. There are several different types of capacitors. Electrolytic capacitors. These provide high capacitance values and are commonly used in power supplies and filtering circuits. Ceramic capacitors. These are small, inexpensive, and widely used in electronic devices. Film capacitors. These offer excellent stability and reliability and are often found in audio and industrial equipment. Tantalum capacitors. These are compact and provide high capacitance in a small package. Supercapacitors. These can store significantly more energy than traditional capacitors and are used in energy storage systems and backup power applications. Each type has unique advantages and is selected based on voltage requirements, capacitance, size, and cost. Application of capacitor. Capacitors are used almost everywhere in electronics. Power supply filtering. One of the most common uses is smoothing voltage fluctuations. Capacitors absorb unwanted ripples and help provide a stable output voltage. Energy storage. Camera flashes use capacitors to store energy and release it instantly when taking a picture. Signal coupling. Capacitors allow alternating current signals to pass while blocking direct current. Timing circuits. Many electronic timers and oscillators rely on capacitor charging and discharging rates. Motor starting. Certain electric motors use capacitors to create the starting torque needed for operation. Audio systems. Capacitors help improve sound quality by filtering unwanted frequencies. Renewable energy systems. Solar and wind power systems often use capacitors for power conditioning and stabilization. Importance of capacitor.
Without capacitors, many electronic devices would not function properly. They stabilize voltage, store and release energy, filter electrical noise, protect sensitive components, improve efficiency and performance. Even though they are often overlooked, capacitors are among the most important building blocks of modern electronics. Conclusion. To summarize, a capacitor is a device that stores electrical energy in an electric field. It consists of two conductive plates separated by a dielectric material. Capacitors charge, store energy, and discharge when needed. From smartphones and computers to industrial machines and renewable energy systems, capacitors are everywhere. The next time you use an electronic device, remember that behind the scenes, tiny capacitors are working continuously to keep everything running smoothly. Thank you for watching. If you enjoyed this video, don't forget to like, share, and subscribe for more electronics and engineering content.